Assalamu alaikum wa rahmatullah. Welcome back. This is Dr. Muhammad Saad, and we are still continuing our lectures on random signal theory. In this lecture, we will start with a new chapter, with chapter 3, which is called discrete random variables. So we will start talking about something called the random variable, as opposed to the previous chapter that talked about random experiments and sample spaces and events and basic probability rules. Now we will start talking about random variables, and more specifically, we will talk about the discrete random variables. In the next chapter, in chapter 4, we will be also talking about continuous random variables. Now, what is a random variable? So formally speaking, a random variable is a mapping from the outcomes of a random experiment. So we have a random experiment and the sample space has outcomes. Each outcome of the random experiment is mapped to a number. So these possible number values are called the random variable. Now the best thing to do, maybe this is not very clear, but the best thing to do is to see a motivation example right away. So I'll move to my own notes here, and we will use the following example as a motivation so that we understand what the random variable is. So let's say we have the following experiment, like what we talked about in chapter 2. We toss two coins and we observe the outcome. For this experiment, what was the sample space? The sample space had four possible outcomes: heads, 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 tails, tails, heads, and tails, tails. So this is the experiment. We toss two coins and we observe the outcome. And that experiment has a sample space which contains the four outcomes: heads, heads, until tails, tails. Now we define a variable. Now the variable should be a number. As the word variable says, it might be unknown, so the value of the variable might be unknown. However, our variable here is related to the random experiment, and it has a certain meaning, it has a specific meaning. Now in this example, let's say we define a variable x, which is equal to the number of heads obtained, the number of heads obtained. Once we do the experiment, again, I give you the two coins. I ask you, please toss the two coins. Of course, we understand that the sample space contains heads, 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 tails, tails, heads, and tails, tails. And then I tell you, okay, now let's define a variable called x. By the way, for random variables, we use the uppercase letters. We use the capital letters. So this is a capital X and uppercase X. We let x denote the number of heads that you have obtained. Now, if you toss the two coins, what are the possible number of heads that you can see, which will be the value for x? Obviously, in that context, the variable x, which again denotes the number of heads that you obtain, is either 0 or 1 or 2. We don't have any other possibility. So the number of heads, or variable x, cannot be something negative because it represents the number of heads. It can be 0 in case we get tail, tail, and it can be 1 in case we get heads, tails, or tails, heads. It can be 2 in case we get heads, heads, but it cannot be 3. That's also not a possible value. So our variable x can be 0 or 1 or 2. And that variable, as you have seen, is actually related to a random experiment and to a sample space, because that variable x was defined as the number of heads that you obtain if you toss two coins and observe the outcome. So when is x equal to 0 again? If you get the outcome tails, tails, then x is equal to 0. If you get one of these two outcomes, if you get heads, tails, or tails, heads, then x is equal to 1, because x denotes the number of heads. In these two cases, we have only one head. And when is x equal to 2? In case we get heads, heads. So as you have noticed, our variable x that we have defined in the context of the random experiment and the sample space, that variable x is 0 or 1 or 2. Before we proceed, how does this variable compare against the variables that you are used to in a calculus course? So we also dealt with variable x, but usually it has a lowercase letter, a small letter. This was a deterministic variable. So although it's unknown, it could be unknown, I don't know the value of x, but once we have the equation to solve and we solve it, we get the value. So we say x is 5 or x is 2, but in any case, that variable x has only one value. So that value could be unknown, but once we find it, it is one value. So that's why we say it's a deterministic variable. But in our context here in this course, that x variable could be 0 or 1 or 2. Of course, these values are related to a random experiment, But however, if we just focus on variable x, that variable x is either 0 or 1 or 2. So in other words, so that we are complete, what is the probability that x is 0? And what is the probability that x is 1? And what is the probability that x is 2? That obviously depends on the experiment. So when is x equal to 0? When we get tail-tail. What was the probability of tail-tail? It was 1 over 4. Remember, the probability of each one of these outcomes is 1 over 4 because we have equally likely outcomes. It's a fair coin. We have equally likely outcomes, and we have 4 different outcomes. So each one has a probability of 1 over 4, and we talked about that in chapter 2. So the probability that x is equal to 0 is 1 over 4. The probability that x is equal to 1 is 1 over 2, because we have 2 outcomes that give us x equal to 1 here. 1 over 4 plus 1 over 4, so a half. So this half is actually a quarter plus a quarter. And the probability that x is equal to 2 is also 1 over 4, because x is equal to 2 when we get heads, and this has a probability of 1 over 4. So what you see here, this is precisely how we express a random variable, a discrete random variable. Why is it discrete, by the way? It's discrete because the different values of x are basically coming from a set of numbers, a discrete set of numbers. So we can count and we can point to the different values, 0 or 1 or 2. And this is opposite to a continuous range of numbers. So we're not saying x is anything between 0 and 2. This would be continuous. If we say x is anything between 0 and 2, including the 0.0001 and including the 1.999 and everything in between, in this case it would be continuous. But here x is discrete because it is coming from a discrete set. منفصل بالعربي كده منفصل, which means discrete. Now what you see here is precisely how we express a discrete random variable. So we have a capital letter which represents the name of the variable itself, and then we have the different values. We say x is 0 or 1 or 2, and each one of the values comes with a probability. So that variable x would be equal to 0 25%, and it would be 1 50%, and it is 2 25%. Of course, these values come from a random experiment. But once we forget about the random experiment, we can be dealing with the variable itself, and this is what we will see in the rest of the chapter. So this is precisely what we say here. So isn't it true? Isn't it true that the variable values 0, 1, or 2 are actually related to the outcomes of the random experiment? So each one of these outcomes is mapped to a number. But it is not just any mapping. It is a mapping that has a specific meaning, as in this case here, each outcome is mapped to the number which represents how many heads we have. We could have defined this differently. If we define x to be the number of tails obtained, then we have still 0, 1, and 2. However, the probabilities would also be the same. But 0 would correspond to heads. 1 would correspond to this, as you see it, heads, tails, or tails, heads, and 2 would correspond to tails, tails, because we're counting the number of tails. Anyway, let's just stick to this x variable, this random variable x. You can also think of it, so that we understand the definition here, you can think of it as a mapping from the outcomes of the sample space. So each one of these outcomes is mapped to a number. So this outcome is mapped to number 2. And this outcome is mapped to number 1. This outcome is also mapped to number 1. And finally, tails is mapped to number 0, right? So each one of the outcomes is mapped to a number. And these numbers together, we can think of them as a random variable x that is either 0 or 1 or 2. In this example, 0 or 1 or 2, each one coming with a probability. I think now we understand the definition. A random variable is a function or mapping. Function is always a mapping or function that assigns a real number to each outcome in the sample space of a random experiment. So we have a random experiment that has a sample space, and the sample space has outcomes inside the brackets. Each one of the outcomes is mapped to a real number. That's what a random variable is. A random variable is said to be discrete. So we have a discrete random variable if the values are taken from a set of numbers. That set of numbers could be finite, as what you see here, 0 or 1 or 2. It could be infinite as well, by the way. It could be infinite as well, but it has to be countable all the time. So if we have, and we will see examples like this, if we have a variable x which is 0 or 1 or 2 or 3 and so on until infinity, it's still discrete. So it goes until infinity, but it's countable because we have 0 or 1 or 2, so we can point our finger to the different values. And this is not the same as the range x greater than or equal to 0. This is continuous because we have everything from 0 onwards, including the 0.0001 and all the fractions as we go. Okay, so I hope this is clear. And here we have just an example so that we can see how we can construct a random variable, or what are the different values that this variable can take. So in this context, let me read a voice communication system for a business, like the telephone system of our university, contains 48 external lines. So we have 48 telephone lines that can be used to call outside. At a particular time, the system is observed, and some lines are being used. Of course, some of the 48 are being currently used, and some of them are currently not used. Now we define a variable x. Let the random variable x denote the number of lines that are being used. The number of lines that are being used. In that case, what are the different values for variable x? What are the different values for variable x? Can x be 0? So if I observe the system and find that none of the lines is being used, all of them are not used, all of them are available or empty, in that case, x is equal to 0. So x can be 0 in this context. X can be 0. If we observe the system, and then we find that there is only one line being used, then x is equal to 1. If we observe the system and we find that 2 lines are being used, then x is equal to 2. Finally, we can move on if we observe the system and we find that all 48 lines are being used. If this happens, which is possible, in that case, x is equal to 48. So our variable x here in this context, as defined in this example, is 0 or 1 or 2 until 48. So unlike this one, which is 0 or 1 or 2, in this example, x is 0 or 1 or 2 until 48. So 3, 4, and so on until 48. Of course, to define this random variable completely, each one of these values comes with a probability, but that's not given in this question. In this question, the scope is just to find out what are the different values of our random variable. So our x variable here, instead of being deterministic as in calculus 1 or calculus 2, no, x is a random variable, so it could be 0 or 1 or 2 until 48. Of course, the actual value that x will take depends on the experiment. So if we go and check that telephone system, and if we find out how many lines are being used, then we have a value for x. Now, let's look at the next example here. So in this example, we say that we're sending a number of communication messages. We're sending 4 messages over a communication channel, over a digital communication channel, and then we define x as the number of messages that arrive with error. The number of these 4 messages, the number among the 4 messages that arrive with error. And now, what are the possible values for x in this case? So if I'm sending 4 messages, how many messages of those could be possibly arriving with error? I mean, if all of them arrive correctly, then the number of ones that have an error is 0. I mean, the number of messages that have an error is 0. If you're sending 4 messages, it is possible that 0 of them have an error, or 1 of them has an error, or 2 or 3 or 4, and that's it. So our variable x in this context is 0 or 1 or 2 or 3 or 4. Why? Because x is defined as the number of messages that arrive with an error. So in case we have no error, then x is 0. And in case all of them have an error, then x is 4. And all the values in between 1, 2, and 3 as well, depending on the number of errors that we get. But obviously, x cannot be negative because it is the number of errors which cannot be negative. It cannot be 5 as well because in total we have 4 messages. So x is 0 or 1 or 2 or 3. It is given, this is given in the question. It is given in the question that the probability of x equal to 0 is 0.6561. The probability that x is 1 is 0.2916, and so on. So these are the probabilities of the different values of x. In other words, the probability of no error is 0.6561. The probability of one error is 0.2916. The probability of two errors, 0.0486, and so on. The probability of four errors is 0.0001. This is given. So how would we express this random variable in our usual way? How would we express this random variable in our usual way? We would express it as follows. We would say x is equal to 0 or 1 or 2 or 3 or 4, and each one of them has a probability which are just given. So if we put everything together, that's how we can express variable x. Okay, so as you have noticed, variable x, we use a capital letter or an uppercase letter for the variable itself, and we have the different values of the variable, and then we have the different probabilities of the variable. Now, to set things straight, to come up to a conclusion here, we can think of these probabilities as a function on the variable values. You know, the function is always a mapping, so each variable value is mapped to a probability. So we can think of these probabilities as a function f of x. We can think of these probabilities as a function f of x, which is just defined as the probability that the variable is equal to some value small x. In other words, f of 0 is the probability that x is equal to 0, which is this value 0.6561. F of 1 is the probability that variable x is equal to 1, which is 0.2916, f of 1, and so on. F of 4 is the probability that the variable is equal to 4. By convention, by the way, we use the uppercase letter for the variable itself, and we use the lowercase letter to indicate a value for the variable and to indicate these values. So if we say x is equal to 3, like one particular value, we can use the small letter. But as long as we talk about the variable itself, which could be this or that, and so on, we use the uppercase letter. That function here, which reflects the probabilities, is called the probability mass function, that we can draw as well. So we can draw this function here. On the x-axis, we put the different variable values for this example, 0, 1, 2, 3, 4. And on the y-axis, we put f of x, which is the probability. So what was the probability that x is equal to 0? 0.6561. X is equal to 1, 0.2916, and so on, and each one of them has a dot. What you see here is called the probability mass function that represents the probabilities of a discrete random variable. Now, finally, before we stop this video, this probability mass function has some characteristics. So let me start with the last one here, which is just the definition of the probability mass function. What was the meaning of little f of x? It means the probability that the variable is equal to a particular value. So this is what we said here. That function that is called the probability mass function is the probability that our variable is equal to a particular value. Since that function f of x represents probabilities, probabilities cannot be negative, so the function values are all greater than or equal to 0. Finally, since this function f of x represents probabilities, the sum of all probabilities must be equal to 1, and this is something that you note in all the examples that we have seen. When we constructed this x variable, the probabilities, if you add them up, the sum is equal to 1. A quarter plus half plus quarter is equal to 1. In this example in which the probabilities were given, if you add up all these numbers as an exercise, do that, the answer is equal to 1, and so on. So this is an important characteristic as well for the probability mass function. Assalamu alaikum wa rahmatullah. See you in the next video, inshallah.